Hey friends, welcome to this video. In this video we're going to talk about this. This is a current sensor which is called ACS712. This sensor can measure amperage. In this case this is 20 amp one, the version of 21 of this. You can get 5 amp of this, 20, even up to 30 amp of this. This is called half current sensor measure. You can get it very cheap. For example, here you can get it about $1 to $2. This is very cheap one. So in this video we are going to talk about this. Not just this, we're going to make some sort of power meter, a watt meter. So we're going to measure two things: the voltage and the current. Of course we measure the current by this sensor and voltage by voltage divider, and we do this all with the Arduino. So let's put this aside. The first thing we need to do is measure the voltage. To measure the voltage we can directly measure voltage by the Arduino, but we just only can measure up to 5 volt. So to measure higher voltage we need something called a voltage divider. It's something called like this. So the first thing we need to do is we need to make something called a voltage divider. A voltage divider is made of two resistors. Here we have a source. In this case my voltage, it is 15 volt. We take that and connect it to our resistor and connect another resistor series with that one and connect that one to the ground. From the middle point we take the divided voltage and we connect this pin to any of Arduino analog pin, in my case A0. As you know, Arduino can read from the 0 to 5 volt. So we need the voltage from 0 to 5 volt. We can directly measure the voltage with the Arduino from 0 to 5 volt, but you can't measure 15 volt. That's why we need a voltage divider. So to find the values of the resistor, that's not something hard. We have a formula for that one. We have the formula V out is equal to Vn times R2 divided by R1 plus R2. This is an easy formula to calculate the V out. In my case, my R1 is 2.2 kilo ohm and my R2 resistor is 1K. Let's measure how much is our divided voltage. We have the formula V out equal to Vn. In my case it is 15 volt, so we write 15 volt. This one times R1, in my case this is 2.2. Sorry, R2 is 1K, which is 1000 ohm, divided by R1 plus R2. So 1000 plus 220. Let's calculate this. You're going to use a calculator to calculate. First of all, 100 plus 2.200 is 3200. So 1000 divided by 3200 is 0.3125, and this one divided by 15 is equal to 4.68. So our Vout is 4.68, which is lower than the maximum Arduino voltage can read. It's 5. So whenever our voltage is 15 volt, we read 4.68 volt in this divided pin. So you can measure any voltage from 0 to 15 volt very easy by using this voltage divider. Now let's do it in action on the breadboard and measure this middle voltage with a multimeter. And after that we're going to measure that with the Arduino. So let's do it. Here's my breadboard. I'm using 1K resistor and also 2.2 kilo. So let's connect them just like the schema we did on computer and measure the middle divided voltage. First take 1 kilo resistor. This is my 1K and this is my 2.2K. This is my R1, 2.2 kilo. And this is my R2, 1 kilo. This is the middle point where we should get the divided voltage. So I'm going to connect the wire in the middle, and this is my VCC pin, and one more for the ground, and this one is for my ground. Now let's use a power supply to power this thing. I connect the positive to here, and I'm going to connect the negative to the shorter wire. Connecting the negative just like this. This is my power supply, and let's connect the multimeter to this one. The ground to the ground, and my multimeter positive come to the middle pin of the voltage divider. Let me turn on the now let's power the power supply. I'm going to apply 5 volt. You can see it's 5 volt, and we read 1.9 volt in the multimeter. Let's power it 10 volt. We get 3.13 volt. Let's power it a little bit more. My power supply maximum power is 14 volt. So whenever it is 14.3 volt, I read 4.4 volt. As you can see, whenever our voltage is 15 volt, we get 4.68, and in this case our voltage is 15.4, and we get 4.497, which is just like what we did on the formula. So the voltage divider works very good, and now it is very safe. We can hook up this one to the Arduino, and no matter our voltage is 5 volt or 10 volt, we can clearly measure from 0 to 15 volt with the Arduino. Now let's hook up this one to the Arduino and measure the voltage into that. So here what I did is I connected my Arduino, and I use an OLED display to display the voltage, and this is my voltage divider. and I hook up this one to my power supply, as you can see here. So any voltage we insert to these pins, we can read it directly by this OLED display. Let me set the voltage from the power supply. 4.2 volts. Let's see what we get here. As you can see, we get 4.2 volt in the OLED display. If I increase the voltage, you can see we get 8.8 volt, 10.2 volt, 12.6 and 14.3 volt. We can measure very safely from 0 volt to 15 volt. So just like that, you can measure from any range. You can measure up to 100 of voltage by using a voltage divider, just using the formula, and that's it. Now let's check the code of this one into the computer and see how it has worked. This is our code. The first thing we did is we included the library for the OLED display. We made an integer for analog input, a float for Vout, Vn, value, and also two float for the resistor values. As you can see, this is R1 and R2. Because our resistance is not very accurate, our resistor is not 1 kilo ohm or 2.2 kilo ohm, that's why we need to first measure the correct value of our resistor and put that value into this float. In my case, my R2.2 resistor was not 2.2, but it was 2179, so I just wrote it here, and my 1k resistor was not 1000, it was 990, so I just write that in this float. And what next I did is I made a value called this analog read. By using analog read, I can read the value from my analog pin, in my case analog input, which is pin 0, A0, and I made a Vout. I divided the value from my analog read to 5 volt and divided times that to 5 and divided by 1042, so you can get a voltage read. And then what I did was I took that Vout and divide that by using this formula. And I also did a if function. If my Vn is smaller than 0.09, I always get a 0 volt and a very small delay, and I display that to the screen. That easy. So as you see, it was very easy to measure voltage with the Arduino. Now what we're going to do is we're going to measure the current by using the sensor. The sensor has 3 pins: VCC, Vout and ground. The VCC goes to the 5 volt of the Arduino and ground to ground, and the Vout, the out is the voltage we get to read by Arduino pin, just like the voltage divider. This is the middle one, the voltage we're going to read. So whenever there is a current flow into the sensor, we're going to get a value and Vout. Let's hook this one to Arduino. The first thing we're going to do is connect the VCC to 5 volt and ground, and I'm going to connect the out to Arduino analog pin 1. Just like this. One thing important, this sensor can read the positive flow voltage. It means you should connect your positive from the supply and here the positive of your load, so you can measure that. If you connect the ground, it now works. So now let's connect a power and load into this, just like this. This is my sensor. I connect the VCC, the power in it, and the other pin goes to the load, to the positive of the load, and also the positive of my power supply. And another pin, the Vout, goes to my Arduino analog pin, and my divider also go to my voltage divider pin, also go to A0. So we can measure the current now by using this sensor. Yes, let's do it. I'm going to use this chrome wire for load test. So what I did, I hook up a positive and negative wire. So my positive wire from the load goes to one of this module pin here, and my another pin is from my power supply, which is the positive one. We connect that one to the another pin of this one, just like the diagram I showed you. And I've connected everything here, and I connect this one to my power supply, just like this diagram. Now let's write this code and upload that code to Arduino. So this is my code. This part was for voltage, and this is the part for my amp. The first thing I'm going to do is I make a float, call it amp, and I do an analog read to read the value from the sensor into my analog pin 1. Then I amp equal to 500. So maybe you ask, what is this? Let me first delete this part and show you guys what this is. As you can see, everything is connected and there is no voltage or current applied to the load, but our sensor show 510 value, analog read value, whenever there is no current flow. So what is that? That is the value get whenever there is no load connected. So we need to minus that to read the correct value. That is why we read the analog read value from the sensor, we minus that to 510. That's the reason. So this is why I minus my amp, which is the analog read from the pin is 1, minus that by 510. Then what I did is I divide this one to 5 volt and times it to 5 and divide that by 1024 to get a voltage. What I get is 0.1 volt per amp. So I need to divide it by 10 to get my real amperage. And then what I did was to display the amperage. Let's upload this code and see what we get. As you can see, now we get 0 amp and there's no load into my sensor. Now let's apply some voltage to get some current. I'm going to apply I just applied about 0.5 amperage. Here, what do we get? Let me make it some little bit higher. Yes. Now half of a volt, half of a current, and this is what we get. As you can see, 0.5 amp. Now let's go a little bit higher, about 1 amp. As you can see, there's the amperage. You get 1 amp, which is very close to our power supply, which is 1.14, and very close, 1.1 amp. Let's go a little bit higher, 1.5 amp. You can see we get 1.5 amp. Now let's make a watt to measure the watt. To measure the watt, all we need to do is making a float called watt and equal to amp divided by Vn. It means we divide amperage by voltage. That's what we get watt, and just display that. Let's upload and see. So here it is. I applied 1.5 amp, 1.45, just like that. So maybe you ask why there's a negative, because we connect our pins in reverse. Let me just move this one and connect this one to here and this one to here. Now you see our negative is removed, and this is our watt. You can see this is the value for the watt. Let me put some current on it. Yeah, this is a watt. So my power supply cannot apply more than 1.5 amp. Let's hook up another power supply and put some high current and see. So I hook up this one to my another power supply, and now let's put a little bit more current and see what we get. You can see 3 amp. As you can see, .2 amp. Let me go a little bit higher. 3.3 amp. You see, the nickel wire became hot. Let's go a little bit higher. 4 amp. We can read the voltage, the amperage, and the watt. You see, nickel wire became really hot. Let's go a little bit higher. Oh, 5 amp. This one became really hot. It can burn my table. Let's go a little bit higher, lower. 2.4 amp is good. So you can see we can read the voltage, the amperage, and the watt. Read the voltage by using a voltage divider, the current by using this sensor, and also the watt. I hope you guys learned something. If you have any question about anything you didn't understand in this video, just let me know in the comment. And if you like this video, make sure to like and subscribe. I put the link for diagram, code, and everything in the description. If you have any question, just let me know. Please share it with your friends, and thanks for watching this video, and make sure to watch my other videos too. Have a nice time.